Hey, this is a quick lecture video for Unit 3-2 covering perception. So we just covered sensation, which is our ability to pick up stimuli from the environment and turn it into something our brain can understand. So the next step, obviously, is what's the brain going to do with it? It's what we call perception. Three main learning goals, and again, we saw a lot of this in class, so I'm going to keep this short. Knowing the difference between bottom-up and top-down processing. Perception is the top-down. Our brain has experience, especially as we move throughout life. We learn more and more, and we know what we want to see, what we expect to see, and that kind of can change and dictate what we end up seeing and hearing and sensing, etc. The brain develops the ability to selectively perceive. Talk about selective attention and the invisible gorilla. And then lastly, our brains learn patterns that allow us to more easily understand the world. So two basic ones for this general level psych class is how do we see distance, depth perception, then how do we make the world simpler? How does our brain break things down and kind of simplify? Think about like your old school math class where you're turning the fraction 4/16 into 1/4. Like how do we make that easier? How does our brain simplify all this input coming in? Our overarching idea, sense happens out in the body, the eyes, the ears, the tongue. Perception happens in the mind. Again, we saw these in class, or these shiny legs. If you were in class, you know that that's not a shiny, greasy leg. That is a painted-on leg, right? So your experience has changed how you perceive those legs. Do you see motion? The dolphins, we talked about all these in class, right? You might remember this video where it's a short audio clip that sounds like rope, 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 rope. But then when they tell you what to expect, you can actually hear what they're saying in the sentence. The train is at Central Station, or whatever the sentence was. Green Needle and Brainstorm, of course, again, talked about in class. All right, so sense, a quick recap, happens out in the body, in the eyes, and the cochlea, in the ear, in the tongue, in the olfactory bulb, the sensory neurons in the body, etc. It's transduction. Perception happens in the brain. Kind of moving to the second step. So perception, selection, organization, interpretation of sensory input, again, happening in the brain. At all times, there is massive amounts of information coming into the brain, and it has to determine what's important, what do these things mean, what's going on around me at any given time. And of course, the more you experience, it kind of manipulates and changes how we're seeing the world. You can tie in a lot from last unit with attitude and stereotyping and that kind of stuff. Those are all top-down processes. So bottom-up versus top-down. You probably remember the cowboy on the horse. When you're first looking at it, it's bottom-up process. Your brain has no experience. It doesn't know what it's looking at. It can't really take any meaning, but you are sensing it. The light is going through your eyes, and there is a message getting to your brain. Bottom-up, think about your eyes are lower than your brain. It's going from the eyes up. Whereas once I showed you the outline and knew it's a cowboy on a horse, your brain knows what to look for. It's top down. So your experience can manipulate what you see in that picture. I know all I see now is the cowboy on the horse. So again, bottom up is sensory, top down is perception. So learning goal number 2. We have the ability to selectively perceive stimuli that's important to us and block out the rest. So 2 key words here, selective attention, habituation. So what if we could sense everything? We talked maybe a little bit in our class about people who have autism or on the autism spectrum. One of the most common characteristics of autism is that their brains lack the ability to block stimuli out. It's painful. And if there's too much coming in, if your brain is dealing with too much stimuli, things are going to be really tough. So, talk about 2 different things. One's a review, sensory adaptation. This is when we have constant stimulus. So whether you're being pinched at the same pressure level, or you're in the same stinky room, or you're in the same cold pool, after a certain amount of time, that stimulus is going to be ignored by your senses. Right? So that message is not going to reach your brain at all. Sensory adaptation, you can't go back and re-smell the stinky room unless you leave. change the amount of stimulus, and then come back. You can't think to yourself, oh, this pool is going to be cold again. You have to get out of the pool and then jump back in. The message is not reaching the brain at all. It's a sensory process. Versus habituation, the message is still getting in. It's just that your brain has decided, oh, this is not that important anymore. If you remember seeing the rat, the loud noise, and even a lot of you in class jumped, but after a few instances, you stop jumping. The rat stopped jumping. It doesn't care anymore. It can still hear the sensory part of the sound is still there, but in the brain, you know it's not that important. It's kind of like falling asleep with the TV on in the background, or there's I know my sink was leaking a couple weeks ago, and just the drip, 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 drip. After a while, it didn't matter anymore. My brain had blocked it out, even though I could still go back and hear it if I wanted to. It's habituation. It's a perceptual concept. Selective attention, blocking out certain things that your brain is seeing as not that important and focusing on things that are relevant to you. A few different instances. We saw this in class. The gorilla, of course, can walk through, and most of us don't notice it until we know that there's something there. Most important kind of selective attention is inattentional blindness, at least in our course, which is failing to see visible objects when our attention is directed elsewhere. It's the example of the invisible gorilla. The cocktail party effect does come up on the test. This is an auditory selective attention where you can listen to one person, even though there might be tons of noise in the room. Last learning goal here. So, two kind of basic ways our brains do put things together perceptually is number one, we see depth, we see distance. The world isn't a flat place, even though the light that's reflected onto our eyes is flat. The retina is a two-dimensional space. And then gestalt, which is the way that our brains simplify complex sensory input. So think of all the things that are coming, all the information that's coming in through your eyes. How do we make sense out of it and understand it easily and quickly? We simplify. So depth perception, the ability to see objects in 3 dimensions, allows us to judge distance. Don't overcomplicate this. Depth perception means distance. This was shown back in the 50s by a parapsychologist named Gibson and Walk. They would put the babies on this table with a glass top and have the mom call the baby across. The babies generally would stop. They wouldn't crawl out across the glass because they think they would fall. They can see depth. They can see that there's a cliff there. Imagine if the world was 2D. None of us would live very long, right? So our brain develops the ability very early on to see distance. So there's a few different ways it does that. Number one, binocular cues. Retinal disparity. In class, we held our hands out like this, and we'd go camera 1, camera 2. Look at the different images in the left eye and the right eye. Your brain knows that the farther away those images are, so look at something close, your hands don't jump that far. If you look at something far away, the image jumps much further. The farther away those retinal images are, your brain knows that whatever you're looking at that moment is further away. Number two, help with things that are flying at you or getting really, really close to you. A binocular cue called convergence, which means take your finger, look at yourself in the mirror, and as your finger moves closer to you, your eyes converge together. Your brain knows that when your eyes are coming together, looking at something, you got to duck. It's getting close. So these are what's called binocular cues. You need to have 2 eyes open in order to use these as depth cues. Retinal disparity because you need the 2 images, and then convergence, same thing. You need both eyes that converge on the one object that's moving close to you. Other depth cues are monocular cues, or you can only need 1 eye. You can close 1 eye, or you can look at a flat surface and still see 3 dimensions. Number 1, relative size. Things that we know are about the same size, like 2 chairs or 2 people. If one looks way smaller, our brain assumes that it's farther away. If it looks bigger, we assume that it's bigger. We're not blown away by oh my God, look at that car shrinking as it's driving away from me. No, it's not shrinking, it's just getting farther away. It's an assumption our brain is making about distance. Relative size, you see some examples here. Again, in all of these pictures, you see almost all of the depth cues. So here, you can see texture gradient. I can see his face, can't see his. Relative size, he is huge, He is tiny, but we know they're about the same size. This isn't like a little person on a boat. This is a normal person on a boat that's further away. Normal size person, I should say. Relative height or horizon. The lower on the horizon, if this is the horizon up here, the lower on the horizon, the closer things are to you. So you can see all these depth cues in any one given picture. Linear perspective, parallel lines, look down a hallway. A lot of you did this for your assignment, photo gallery assignment. These lines aren't coming together in reality, they're just getting further away. Our brain is assuming they're getting further away. They're remaining parallel. Hallway. Interposition or overlap. If I can see all of you and only part of somebody on the other side of you, my brain assumes that you are closer. These cards, even though this is 2D, this card is closer to me than this card. This card's on top. I can see all of it. Horizon and motion parallax. Motion parallax is tough to, you can't demonstrate this unless you have a video or something moving. But objects that are closer, or we perceive as closer, we perceive as moving more quickly by us, right? We use the locker example in some of the schools. If you look at this Mario Brothers-esque video, that we know the bushes are closer. Not only are they overlapping, but they're zooming by, right? The things that are farther away appear to be moving more slowly. Horizon, same thing. Look down right next to you, and then look up to the horizon. The farther you get, the closer you get to the horizon, the farther away things we're assuming that they are. Again, all of these examples. Texture gradient. Closer things are, the more detailed they are. The farther, our brain's assuming that it's farther away. I can see all of these bricks. It just looks like a regular sidewalk down there, or a uniform color. I can see every blade of wheat. It just looks like a green line. The more detailed things are, the more close our brain assumes that they are. All right, and then lastly, Gestalt. Organized whole perceived as the sum of its parts. So we don't have to look at, we see a bookshelf, we don't have to go, oh, there's 19 books there. We can just say, hey, there's books, right? We don't have to walk into a room and say, oh, there's 37 desks. You can walk into a room and say, there's a bunch of desks, or there are 6 rows of desks, or there is a row of desks. Our brain simplifies what it's taking in for speed reasons, right? Gestalt principles are used to make order out of perception so that we can see things as connected and not just random bits of information. The world is a whole. So there's a few different examples. Proximity, things that are close together will be viewed together visually. This is on the test. So reading works like this. These letters go together because they are close together. There is a space here. So these letters go together. Proximity. How hard would reading be if it was all spaced evenly? That's like the way Eli writes. It's a headache. Closure, the brain, this is top-down processing. The brain is good at filling in gaps to create a whole. So this is not like 9 or whatever, probably closer to 12 or 15 random lines. This is a square because I know what a square looks like. My brain can fill in the blanks, right? Top-down processing. Similarity, things that look the same, we group together. I do this when I write on the board. When I write on the board, I tend to write in different colors. And I don't write every letter in different colors. I write things that go together, usually go in orange. And then another group of things that go together go in blue. It's because your brain is grouping those things together. And I want them to be grouped together like that. Whether it be senses in blue on the board and perceptions in green or whatever. I use Gestalt to help you understand what I'm writing on the board.